Dr. Swell, thank you so much for taking the time to visit with me. You are somebody that I have followed for a long time. The amount of times I get sent different clips or podcasts that you're done is like, this is a doctor that's talking about sunshine. Have you heard of this guy? And so, anyways, it's really cool, and thank you for the work that you've done. If you don't care to give us that little bit of a brief introduction, because it's the credentials are definitely there for you to be knowing what you're talking about on this.
Well, thanks, Logan, for having me on Sowing Prosperity podcast. Yeah, I'm a physician. I'm a pulmonologist, which means I deal with people who have lung issues. I work in the intensive care unit as well. I'm also boarded in sleep medicine, so I do sleep medicine as well. The pandemic really made me think about things and looking at alternative supply chain independent things that we can add to the toolbox that we already have to not only help us in the acute settings, but also prevent a lot of chronic diseases as well.
Yeah, that was it was a big eye opener for all of us, right? Like that time frame. For me, my little boy was just diagnosed with stage 4 kidney cancer in July of 2019, and then COVID hits first of 2020, and got to see that from a pretty unique perspective as well. But that's really what got me to the whole point of even having a conversation about sunlight. Was it was pretty uh, circuitous walk to get there. But I remember asking the oncologist, like, what do I feed him? Like, right, that was the first thing. He's like, what do I feed my son with cancer, 5-year old, right? And oh, it doesn't matter. I'm like, it just didn't feel right, And so as I dove into diet and nutrition from a cancer perspective, just kept going, kept going, kept going. And it was a long walk, but to get to the point that sunlight impacts biology is not something that I ever would have really, pinpointed. But we got lucky on a lot of things. He played outside. I didn't let him think he was sick. He was a little boy that everything we were doing was getting better. So can you go into a little bit more of your story as a clinician of when what about COVID made sunlight come on your radar? What was that tipping point for you?
Yeah, that's good question. So I would say in the DNA of myself and many of my colleagues that went to medical school where I went to medical school, which is in Southern California at a place called Loma University. That school was founded by a health reformer back in the 1800s by a lady by the name of Ellen G. White, and she wrote a lot about health reform. In fact, she's one of the top 100 most influential people, Americans, that were named by the Smithsonian because of the amount of writing that she's actually done. And really is sort of the basis for what Weimar University has come up with New Start. So she talked about nutrition, how important it is, exercise, water, which we can talk about today, sunlight, which we'll talk about today, um, temperance, the elimination of toxins, alcohol, tobacco, things of that nature, fresh air, rest, sleep, and trusting God. And so, the motto of Loma Linda University, if I could give it a plug, is to make man whole, and it really is emphasizing not only the physical but also the mental and also the spiritual aspects of making somebody whole, truly whole and healthy in that respect. So, growing up in the area, going to medical school at Loma Linda, there was always this emphasis on, for lack of a better term, natural things that we can do that can really improve our and impact us. And for those that don't know, people that live in the Loma Linda area, there's kind of like an area there of centenarians that goes way back, even before Blue Zone. So before there was Buettner, before there was Blue Zones, Loma Linda was sort of on the map in terms of probably the oldest living subpopulation in the United States. So a lot of that was sort of looked at in terms of nutrition and also keeping a day of rest and things of that nature. But where I go with this is that, that as the background, here I am going to medical school and I'm learning about all of the other things, right? So there's a lot of complicated things that you learn in medical school, diseases and how they present and how you need to identify them and treat them. And I use that every day in my ICU practice. So when the pandemic hit and we were employing all of those things that we had learned about in school, how to put people, in the hospital, how to order things, how to give them the things that they need to have to support their bodies, and the things that we do in the intensive care unit, like putting people on ventilators and making sure that they're comfortable and things of all of that nature. There were so many people that were coming in that we had limited resources. We were running out of ventilators. We were running out of medications. We were running out of a whole dialysis machines. I remember specifically people were going into renal failure. And as a result of this, we had dialysis machines and we had the catheters to put into the patients to give them the dialysis. But we didn't have dialysis nurses. Why? Because they were out with COVID and they couldn't run the dialysis machines. And so what really hit home to me, and I looked around at other places here in the United States, like Eastern Washington State, Idaho, Texas. A lot of these places were running out of supplies because of just a tremendous amount of people that were coming to the hospital. Couple that with the fact that it was very well known that people with good vitamin D levels seemed to do better than those that had low vitamin D levels. And so, I put out videos that talked about the importance of vitamin D. Obviously, those studies were not causative, right? They showed association. So we couldn't say necessarily that it was the vitamin D doing the heavy lifting, but we saw that people who had good vitamin D levels did well. So we did a whole video on vitamin D. It actually got over 12 million views back in 2021. And as we started to do the studies which were interventional, like where we're giving vitamin D to people, it just didn't have the impact that I thought it would. And so I began to think that, well, maybe it's not vitamin D itself. And look, I take vitamin D. I think it's a great thing to take. There are studies that show that vitamin D is beneficial in certain other things, but for COVID, it's kind of a mixed picture. I began to see that perhaps there's something about sunlight which makes vitamin D levels go up, but also is doing something else in the human body. And then I began to go back to some of these writings that Ellen White had written about, and she talked about how we need to get out in the sun. Not just her, but even people prior to her, like Florence Nightingale in the 1850s, who said, Florence Nightingale, for those that don't know, she was basically the founder of modern nursing. She really took nursing as an occupation and elevated it to such a high level. She was known as the lady with the lamp. She was there in Italy. She was named after Florence. She was born in Italy to two very wealthy to a very wealthy British couple who did not want her to go into nursing. But she went into it. She really put her all into it. She started to see what was going on. She started to elevate that occupation, started to do hand washing, getting people outside. And she was able to see that people who got outside, people who got fresh air, did much better than those that were actually in the dark, stuffy areas of the hospital. And so, I started to put the science with what we knew historically, and I studied the Spanish flu epidemic, pandemic, and here we are talking on your podcast about all of those things that has taken me about 2 to 3 years to sort of look into this, look at the data, and look at the science behind this, and realize that we've really discarded a whole area of medicine that we used to practice and was the standard of care just 100 years ago. And what I find, and I'm not here to say that we should do that instead of, I'm here to say that we lost that understanding and we should get it back. We should use every tool in our toolbox to make the patient better. And that's really where I'm coming from on that.
I love it. I think that's why I appreciate you so much is it's not a one or the other. You're like, what is the legitimate solution that's gonna sincerely help people? I think, that sincerity is what I sincerely appreciate about you. But when I had the paradigm shift of going from attempting to understand cancer from the somatic cell theory to go into where it's more of a metabolic, like, that was a big shift, right? But I don't think that we go far enough there, and you talk a lot about mitochondria. You talk a lot about these metabolic aspects that, honestly, I don't hear very many allopathic physicians discussing at all. And I think that we still need to keep going deeper with that. So, my point here was you saw a correlation between mitochondrial function, right? and sunlight. And I think this is where we need to start bringing in some of the pioneers within that. To me, that would be, Doug Wallace, right? I think his work is absolutely paramount to the conversation. Heteroplasmy, what's going on? When we start looking at, say, Gilbert Ling, I think that he's an underappreciated hero within the mitochondrial world. You bring in somebody like Gerald Pollack, right? Like that may not sound like he's a mitochondrial researcher, but the water aspect is key. So, can you go into a little bit on what your understanding of utilizing mitochondrial medicine, mitochondrial focus within your practice of, the sickest patients?
Yeah, I mean, it can get very complicated. Well, we could talk about mitochondria, electron transport chain, Krebs cycle, reducing equivalents, ATPases. It's a very complicated thing, but let me make it kind of make it simple for you. And that is that there are 8 simple laws that if we follow these laws, everything else takes care of itself. And the wonder and the science is in figuring out how it happens. But I think we're pretty clear on what it is that we need to do, and the evidence is pretty overwhelming when you look at it. And as I mentioned and alluded to before, it's New Start. So nutrition, good exercise, water. We'll talk about that in a little bit in terms of temperature, sunlight, and that's really one of the keys with the mitochondria as well. Eliminating toxins, air, rest, and then trust in God. So in terms of the mitochondria, look, it's the batteries, right? So nothing works without energy, and so if you, this is why it is so wide reaching. Your immune system, they run on white blood cells, right? White blood cells have mitochondria in them. If they don't have the appropriate energy, they're not going to work. Go down the list. Every single cell in your body, except for red blood cells, has mitochondria in it. And if your mitochondria are not working, those cells are not going to be doing what they need to do. So, if you look at, for instance, sunlight is one of those major things that this year has been a banner year in terms of mitochondrial research. So, Glenn Jeffrey, UCL, showed clearly that light can go clearly through the human body. It gets absorbed all the way through, and it can cause upregulation. And basically, all of the signs that we see of aging that happens in the mitochondria gets reversed when this sort of thing happens. So once you're already there starting to improve mitochondrial health, all of the other aspects of immune fighting are going to be elevated. This is like, the expression, a rising tide, or tide rises all ships. When you're improving mitochondrial health, and they all communicate with each other, we know that there's there's intra and inter-organ communication with mitochondria. Sunlight, infrared light, we believe, and this is getting to Pollock and water and solvents, and we're actually, I'm not going to say too much about it because we're actually coming out with a paper on this that's looking at water, it's looking at solvents, and it's looking at the physics of electron transport, electron transfer, and Marcus equations. So if you look up Rudolf Marcus, he won the Nobel Prize in 1992 for his work in the late 80s on electron transport and lambda, which is the reorganizational energy of electron transport. This is really what happens in the mitochondria. You have electron transport, and you can make that electron transport very easy, or you can make it very difficult. And what we're finding is that the reorganization energy of water, of solvents that are around this electron transfer, can actually be mitigated by infrared light, which is clearly absorbed in those spectrums. But there's more to come on that.
Fantastic. I just read a preprint of Dr. Barry Ninham. I don't know if you're familiar with him. He is a physicist in Australia. Uh, Absolutely brilliant. And if this or when this comes to light, I think it's going to rewrite the game on mitochondria. The Parkinson's paper, but I love that you went there, right? And so, like, can you go a little bit into like the CCO, right? Because we think of like we have byproducts within mitochondrial respiration of CO2. It's just an inert byproduct that just happens to be there, or we produce metabolic water. Like I think that, in my opinion, even the mitochondrial researchers aren't appreciating those facts near enough. So, what are your thoughts?
Yeah, I mean, I always equate it to an engine. So the engine in your vehicle is like the mitochondria in your cells. It produces heat as a byproduct of combustion and locomotion. And the same sort of thing happens in the mitochondria. Just like carbon dioxide comes out of the exhaust pipe of your car, carbon dioxide is created in the mitochondria as a byproduct result of breaking down hydrocarbons, and that gets exhaled out. And the wonderful thing is that really that carbon dioxide is a vapor that is in the atmosphere, and trees literally crystallize that carbon dioxide out of the air and become trees. That's where the carbon comes from that makes trees. It's quite actually very interesting. Sunlight allows plants to crystallize out of the air. But where does that carbon dioxide come from? It comes from metabolism in your mitochondria. What's interesting though is that oxygen is needed, and this is why this is important as a pulmonologist. It's one of my favorite gases because I deal with it all the time. We have to make sure that people have enough oxygen, and that oxygen is turned into water, as you mentioned, and that is a very tenuous, very important and regulated process. At the end of the electron transport chain, you've got four electrons, and those four electrons are deprived of energy, and they really won't go anywhere except to a molecule that's super oxidized, oxygen in this case. It's hard to imagine a molecule more oxidized than oxygen or electronegative, and so it's going to pull those electrons and create water. So those four electrons plus an oxygen molecule creates water. Now the problem is not when that happens; it's when it doesn't happen correctly, and that can happen when there's three electrons or two electrons or one electron. And the byproduct of that are hydroxy radicals, hydrogen peroxide, and superoxide. And your body has to deal with that because those species are extremely dangerous. They're extremely reactive, and the first thing that they bump into, they're going to cause damage to. And of course, since this is happening in the mitochondria gets damaged. This is the analogy that I use for heat in the engine. When those pistons are moving and you're having combustion, that's great. The problem is that metal is going to heat up, it's going to expand, and if you don't deal with that heat, your engine is going to seize up. And that's exactly what happens in the mitochondria if you don't deal with oxidative stress. So, Russell Ryder and Scott Zimmerman published a paper in 2019 called Melatonin and the Optics of the Human Body, which really, for me, was the eye-opening scientific paper. It was the first salvo across the deck that when I read that, I became, first of all, very excited because for the first time, it really coupled together this idea of oxidative stress and oxidative problems in that nature with sunlight. And that was the connection that I needed because prior to that, I had worked out with papers very easily how in COVID, we were having oxidative stress. ACE2 is the receptor for SARS-CoV-2. It's an oxidative stress modulator. You knock it out, your cells becomes more oxidized. And specifically, we're talking about the endovascular cells in the pulmonary epithelium, endothelium that becomes damaged. They release a bunch of von Willebrand's factor, which are little monomers that can polymerize and create blood clots. And these I believe were the people that were coming in with the happy hypoxics. They looked okay, but they were extremely low on oxygen. And for the first time, this was sort of the missing link, if you will. That sort of it was kind of like there was two jigsaw puzzles that were being made, and Scott and Russell's paper sort of was that missing link that brought these two pieces of the jigsaw puzzle together for me. And it was really eye-opening. We published a video on MedCram called "Light as Medicine" in 2022, and that was probably the most excited I was to publish the video and talk about it because it was really groundbreaking to me. So it was Scott Zimmerman, Russell Ryder, that paper, my previous collaboration with all of these other research articles on MedCram, looking at oxidative stress and the cascade of events that occur in COVID-19. And I began to be very confident that sunlight was the solution to all of this. And it's funny because it took us right back to what was in my quote DNA when I was growing up, learning about Florence Nightingale, learning about all these health reformers like Ellen White in the 1800s that said, look, you need to get people outside. You need to get them in the sun. You need to get them fresh air. It sounded really, at the time, before all of this science, sounded like high, kind of nice, and it's nice, but look, we've got all this science and technology in the last 100 years that can make us do so much more. And then I realized that we were missing out on the benefits of all this beneficial stuff that we're not getting inside of a building, inside of a hospital, under artificial lights. And I realized at that point that all of the science and technology that we have is great. It works well. It's a tool in my toolbox, but I was missing out on some major tools that I wasn't employing, that didn't take a lot to actually employ. And that's when I began looking around at the science to see whether there's evidence for latitude, whether there was science for ultraviolet, whether or not patients in different countries did better based on latitude. We published on that. I actually teamed up with Margaret Scutch on that. We published a paper showing that. Richard Weller's article looking at UVA. There was a University of Warwick paper that looked at the surges of COVID-19 in the autumn of 2020 were tied to latitude and nothing else, not temperature, not humidity. Um, all of that. And then finally, the randomized control trial using infrared light in COVID-19 patients in Brazil, only 30 patients in that study. And yet, every single endpoint was statistically significant. At that point, I had seen enough, and I was treating my patients in the hospital by getting them outside.
There's so much, right? There's so much to unpack there and dive in. So, let's go back a little bit to the mitochondria and oxygen, right? Oxygen being paramagnetic, it's pulling through the electron transport chain, right? This is a extremely important piece of that. And so, when we do not have appropriate infrared light and are unable to make metabolic water, we do not insulate that system. Is that an accurate statement there?
Yeah, I think so. I don't know exactly the mechanics of how this works, but we're beginning to see that low energy vibrational energy that we see in infrared light has an effect on the reorganization energies of the electron transfer in Marcus theory, and that's what's enabling or facilitating electron transport.
Yeah. So when we are discussing some of these molecules, carbon dioxide, right? Nitric oxide. All of those are really important. And so I want you to maybe help me as a pulmonologist understand. So when we see something like COPD, right? What we would have done on the ambulance, we got to make sure. I worked EMS for almost a decade. We would make sure that we did knock out the respiratory drive, right? Like, so high flow oxygen. Why that is important, I want you to come back to. On Because CO2 is also a signaling molecule. It's really kind of important that we never talk about. Um, Nitric oxide, there's so much there, right? This is a reactive nitrogen species, right? RNS, ROS. These are signaling molecules, not just negative, and this is why we see actually really bad results when we do high doses of antioxidants within a lot of these therapies in the data, right? So we also have when we see NADH drop, or we have pseudo hypoxia, right? And so, like, I'm trying to tie this back down into what that's based on David Sinclair's work. When we were seeing COVID and you were seeing patients in the ICU, we had them in a really bad environment away from the sun, right? We had them on ventilators. This is changing your world, right? The light piece, I'm very curious if you were able to do any smears and to see if we had like methemoglonemia, right? Did we have nucleated blood cells within some of these COVID patients? Why does that even matter? And why would carbon monoxide poisoning utilizing methylene blue not also be part of it, right? This is where the biophysics comes in that I'm fascinated with. And when we have a charge state of +3, +2 within iron based on light, right? This is the photobioelectric aspects of what's going on, the charge state of molecules. So I know I threw a whole lot out there, but what I've seen with respiratory is fascinating when we're talking about gases and light. And this is something that I don't ever hear anybody talking about, but you as a clinician would be the first one to be able to say, you're crazy, or maybe here's some of the reasons why there may be something.
Okay, so let's talk about carbon dioxide. So yes, people who have COPD are not able to clear carbon dioxide, and that's important because, as you mentioned, carbon dioxide is a triggering gas that is extremely potent for you to breathe. In other words, your body does not tolerate well rises in carbon dioxide. You're going to feel extremely short of breath, even if you're getting plenty of oxygen, if CO2 levels start to go up. But the problem with COPD is that unfortunately they cannot clear carbon dioxide as well. And so CO2 levels over a long period of time will creep up. And so unfortunately, what happens in that situation is that your brain learns to tolerate high levels of CO2. It stops using CO2 as a trigger for breathing and then starts to look at low oxygen as a trigger. And so the problem is that if you get to that situation and you give someone like that a lot of oxygen, they could really slow down or even stop breathing. And that can cause CO2 levels to even go much, much higher. That's why I have a patient right now in the hospital that's in that situation. We have to make sure that we're keeping the oxygen saturations in the low 90s, high 80s, and not at 100% because they could actually stop breathing. So in that sense, you're correct. In terms of nitric oxide, Richard Weller really did a lot of that work. I'll just tell you a brief study that he did back in the early 80s, actually late 70s, before we had very good blood pressure medications. People should know that nitric oxide, which is something that is made naturally in our skin with ultraviolet radiation from the sun, is a vasodilator. So it's going to cause vasodilation in the body all over because this nitric oxide is distributed. Well, it's very interesting. When they did blood pressure measurements across the globe, those people that were closer to the equator, i.e., more ultraviolet radiation, actually had lower blood pressures on average than those that were farther away from the equator. As you went farther away from the equator, there was a range of about 5 millimeters of mercury that was higher as you went to the more extremes of latitude. So again, showing you it's a small but very statistically significant difference between those living at the equator versus those living out farther away. Now, of course, with blood pressure medication all over the place, it'd be hard to repeat that study because you wouldn't have that relationship anymore. You'd have a lot of confounders. But that sort of goes down the same line there that you're talking about. Ultraviolet radiation from the sun packaged with infrared is actually beneficial, not only to make vitamin D, but also to bring down blood pressure. You talked about met hemoglobin, carbon
Before
monoxide.
if you'll
Uh,
care, before we get there,
yeah,
can you go into a little bit on, hemoglobin's ability to release, oxygen with nitric oxide, right? I don't think that that switch is anything that we're ever really talking about either.
yeah. So there's a hemoglobin binding curve that dictates at a particular oxygen tension how much oxygen is released from hemoglobin. It's actually a sinusoidal curve called cooperativity. It's very important. It's not linear because we would not be able to offload as much oxygen as we normally would. And there are certain things that can shift that hemoglobin binding curve. Shifts to the right means that it's giving off more oxygen to the tissue. Shifts to the left means that it's able to grab onto it. There's a number of things that can shift that curve to the right. One of them is 2,3 bisphospho BPG, bisphosphoglycerate, which is basically a byproduct of glycolysis, and this actually goes up in pregnancy. So here's an interesting item. When a woman becomes pregnant, her 2,3 BPG goes up, shifts the hemoglobin curve to the right, and she's able to give off oxygen better to the fetus, who, by the way, has a hemoglobin binding curve that's shifted to the left, so it's able to grab onto it more. So maternal hemoglobin is more willing to give oxygen. Fetal hemoglobin is more willing to accept it. I haven't seen the pharmacokinetics on nitric oxide, but from what you're saying, it shifts the curve to the right as well. So, yeah, there's a whole bunch of things here that are at play, and oxygen is just one of those molecules.
Okay. Awesome. Well, since you brought up pregnancy, can you go into a little bit of embryonic nucleated red blood cells and then tie that into methemoglobin, where I can see that there's probably a correlation there as we get into a little bit. So nucleated red blood cells, embryonic red blood cells, and then methemoglobin. Like how often is that something that you even see within practice? Methemoglobin.
Most of the time in my ICU, we see a little bit of anemia. So this is a situation where we're drawing blood on patients, and they're probably have chronic disease, which means hemoglobin production slows down. we don't see a lot of nucleated red blood cells or reticulocytes, which are the ones right after that. Um, um, Typically, we don't see that. We might see that if we put them on epogen, which is basically a synthetic version of erythropoietin, which is made by the kidney and signals the bone marrow to make more red blood cells. But I can tell you in my COVID patients, I didn't see a lot of nucleated red blood cells.
Fascinating. Fascinating. Okay. So I really want us to get into the temperature stuff. I think that's super important. But before we get there, I want to go into just a little bit of the ultraviolet, right? Because all we ever talk about is vitamin D in, kind of the general conversation there. But I think that it is disingenuous to stop there, right? And pretend like that somehow we can package in a pill and that's going on. So we really need to hit a little bit on POMC, right? Pro opioid melanocortin, what's going on in the cleavage products. I think that's extremely important conversation, especially as you start getting in like beta endorphins and then the parallels within metencathalin, because we're talking about modulating the immune system. And you said, right, in many other interviews, like we didn't see this big benefit just taking a pill, right? A vitamin D pill, right? It wasn't there. Well, because vitamin D levels were just a proxy for how much sunlight somebody was really getting. So this is a other way of laying that out. The cleavage products of POMC, which are UV activated protein. So what are your thoughts on some of this other conversation around UV light aside from vitamin D?
Yeah, I mean, we see this. It's not just vitamin D. Yeah, there are studies that show that taking supplemental vitamin D does reduce acute chest infections. Martineau published that a number of years ago. But the work of Richard Weller, who's a dermatologist at the University of Edinburgh, has shown in a number of studies. There was a study that was done just a couple of years ago. It was a UK Biobank study, 300,000, and they were able to show that basically ultraviolet solar radiation and solarium use, which was measured with sunlight, reduced all-cause mortality, reduced cancer mortality, and most importantly, it did not show a statistical significant increase in melanoma incidence, and certainly not even a trend in melanoma mortality. So yeah, so picture it this way: ultraviolet light, as you eloquently talked about POMC and the endorphins and the pituitary tract and all of that. That's one aspect of it. Another aspect, as we just talked about, is nitric oxide in the skin. Another aspect of it is making vitamin D. So the problem that we have as scientists is that we'll discover something like vitamin D and the fact that ultraviolet light makes vitamin D, and we'll think that that's where it ends, and that's all there is. That there's nothing else. We figured it out. We can now replace the sun based on one aspect of one of the types of wavelengths that come from the sun, and that's really just an egregious use of scientific reductionism, that we can somehow take the benefits of the sun and put it into a pill, completely ignoring the benefits of early morning sunlight on the pituitary tract, completely ignoring the benefits of sunlight on the perihabenular nucleus, completely ignoring the aspects of visible light and its ability to entrain the circadian rhythm, completely eliminating the understanding of infrared light and its ability to penetrate through the body. Now we understand this and cause changes at the mitochondrial level. Yeah, so this is unfortunately the problem. You and I know this, right? People go out, Logan, and people say, "Oh, I'm going to go out and get my vitamin D." That is true. You are going outside and you're going to get your vitamin D, but you're going to get so much more than just vitamin D. And so I think the first thing that we have to dispel, and I have to be honest with you, I was one of these people that just didn't think about it that much. I thought sunlight was vitamin D. What else could it be in terms of real health? Look, if you think, if anybody listening to this, let's distill it down, the sunlight aspect to this one statement here, and I think this would be the salvo here that's going to get people thinking. If you think that taking a supplement of vitamin D is somehow going to replace the need for you to get sunlight, let me disabuse you of that thought right here, right now, and today. There is so much more, even in just, as you mentioned, the ultraviolet spectrum, like POMC, endorphins, things of that nature. Um, that it's such a package that we're now starting to have data that shows that we're not talking about living better. We're not talking about having less disease. We're talking literally survival changes when you're out in the sun. That's huge. That's huge. I mean, even in nutrition diseases, in nutritional research, we'll talk about heart disease, we'll talk about cholesterol levels, we'll talk about all these sorts of things. It's rare that you can actually say they live longer, right? But that's exactly the data that we're getting now epidemiologically when we're talking about getting out into the sun. Yes, the sun that gives you ultraviolet radiation, the same sun that's been demonized for years about it being a deadly laser and you need to avoid it. We're now finding out, and let me just say, this is not just like one side versus the other. The side that has been telling us that it's a deadly laser is acquiescing to this. They are rewriting the policies. Even in Australia, the Australian cancer societies are saying, look, we have to realize that there are benefits with getting outside into the sun. Okay, you can go look it up. You can see it for yourself, and they're realizing that a uh, one size fits all policy is not going to work. People have different colors of skin. People deal with sunlight differently, and so you've got to be smart. You've got to be understandable. I'm not saying, and you're not saying that you ought to go out there and get a sunburn. You ought to have skin damage. Nobody wants to have skin damage. But the right now we're running around in a flood with a fire extinguisher, and the issue I see is not that people are. I mean, there are some people that are getting too much sun and getting sunburned. There's a few amount of people that are going to the beach every single day and getting out there and getting sunburned. What I'm talking about are the millions and millions of people that go to work every single day, and they go to work in their underground. They go in their car, park in the underground structure, go to work in a building that's got low E glass and LED lights. They work all day. They come home. They don't see the sun, and they park in their garage, and they go inside and they turn on a screen. And this is their existence week after week after week after week. And they're not getting outside into the sunlight. For those people, increasing sunlight exposure is going to do nothing but good.
Couldn't agree more. You know, growing up in a rural, Arkansas town, right? Like, I've been around agriculture my entire life, and I think that actually gives me a massive advantage within a temperate climate, right? Because I got to see the changes, and so, like, you eloquently, you were talking about photosynthesis, right? I think, if you go back, there's a little video of Richard Feynman talking about photosynthesis in his unique way. It was beautiful about how a tree can turn into a tree from air and then how it gives back through burning the wood. It was just really cool. But the framework that I have come to, right, going back to the oncologist saying, well, there's nothing, don't just feed your kid. It doesn't matter. Food doesn't matter. To the point that I have this framework has been a long, long time. And Jack Cruz definitely gets a lot of props for my thinking here. But light, water, magnetism, temperature, and time, right? All of it is about of these interconnected things. And I think I see a lot within that new start framework that you use, right? But when we talk about I think it's God's design. I feel like it's laid out perfectly right there in Genesis, right? But when we're having a season, right? You have spring, summer, fall, winter, right? There's differences within each one of those, and then the more temperate or northern or southern, farther away from the equator you get, the more you see that. But we don't embrace the timing aspect of it. We break those timing laws so bad. You said drive into a parking garage, never see the sun. You have artificial light, all of these timing mechanisms from visual and non-visual photoreceptors that we don't utilize, right? And that's a whole nother, conversation that I would love to have too at some point. But the temperature, we never experience temperature change. So, the light, we've completely destroyed that. We don't experience temperature, right? So one of the things that really got my attention as I was looking into like ultra weak biophotons, right? Like that's a whole nother conversation on the mitochondria that's vitally important as well. But within cold, right? The cold therapy. Why is cold therapy? Seeger is a good friend of mine, and we've talked about this a lot. But like when we utilize cold, I'm trying to set this up to get your take. Cold, we have these initiations of like brown fat. Well, why are we brown? Why it's mitochondrially dense. We have melanin, right? Melanin is a UV produced molecule that, and that's, that's not just a tan, right? That's a whole nother conversation tied directly into the melanoma and Parkinson's piece. I think that's worth having a conversation on too. But cold generating UPEs is something that we don't ever talk about either in the mainstream of things. So, with all that said, cold therapy has been one of the most important things in my life, aside from getting the sun, and it is going through that framework of light, water, magnetism, temperature, and time, getting in there, and even more so in the winter. I know I threw a lot at you again there, but what are your thoughts around cold therapy? And then I want to go into hot, but also tie in from we went a lot with mitochondria gases. We completely skipped over UPEs. So if you can hit on that a little bit, as deep or not as you want, and then go into cold, uh, to start bridging a little bit of this together.
Yeah, yeah. So cold and hot. These are two effectors on the human body that I would put under the category of hormesis, right? So these are basically hormesis is this stressing the human body to do something in response that actually can be healthy and beneficial at low levels over a long period of time. If you're stressed in a particular way, you're going to enact changes that is going to mitigate that stress, and that effect is going to be beneficial. And I think that's what we see with cold. That's what we see with hot. There's heat shock proteins, which are unfortunately named because they happen actually both in cold and in hot. You talked about the biophotons and things of that nature. That fits in there somewhere. It may be a signaling thing. We're not sure. At least it'd be nice to see that some studies on that. Here's where I see if I put it all together and my thoughts, I think that where this comes down to hot and cold comes down to circulation. And circulation is very important. You cannot have good health unless you have good circulation. Circulation is what allows nutrients to come to the cells. It also what allows toxins to be taken away. And so what I see here with heat and cold is kind of, they're not separate, but they work together. And this is how I see it working together. Temperature has a huge effect on cells, and circulation is part of how that works. So if you were to use hot, for instance, you're going to get increasing circulation of blood to that area. We know that. You can know that something is red after you apply heat to the part of your body. And the reason is because blood is red and there's now more blood going to that area. So what's going to happen is that heat is going to get into the body and it's going to increase your core temperature. What does cold do now at this point? Now, what's interesting about this is that the purpose of heat is to improve and increase core body temperature. Why is that important? Because heat is going to increase metabolism. Also, there's a huge connection with the immune system. Interferon and a number of other innate immune functions are improved with heat. We'll talk about that in a little bit. But here's where cold comes in, and I understand that you've used cold to your cold plunges. You're in there for 10 minutes or 15 minutes or whatever you're doing, and that's going to, as a reflex, increase metabolic health, increase metabolic rates. It's going to convert white fat into brown fat, which tends to burn things. I know all of that. That's one aspect of it. Where I tend to use cold is in conjunction with heat. So here's what happens with heat, and you'll see this in cultures being used for hundreds of years. They use heat for about 20 minutes. It increases core body temperature. It increases metabolic rate. It activates the immune system. The innate immune system secretes more interferon. And then what cold does right at the end of that heat is it causes vasoconstriction peripherally. Now, what is that? Why is that important? It's because when you pull away heat, that vasodilated blood vasculature on the external portion of your body is where most of the heat is going to escape from. If you use cold to clamp that down, you're going to hold on to that heat for far longer than you would have, ironically, that if you didn't do cold. So in actuality, cold at the end of heat tends to make you hotter longer than if you didn't do that cold. It's counterintuitive, it's paradoxical, but if you understand what it's doing there peripherally, and it and it has to be a brief cold. So this is not something where you're there for, this is literally for 30 seconds, for a minute. And if you think about it, this is exactly what the Swedes, the Finns, the Norwegians do when they go out and they do sauna, right? They're in there and then they jump outside, they go into a cold pool and they jump back in and they go back in inside to the heat to do another cycle of that. The other thing that they do, by the way, is they take birch trees and they hit themselves with the birch trees or the branches and the leaves. And that's another thing that that's been done here in North America 100 years ago is there were some Adventist hospitals in the Northeast during the Spanish flu epidemic. They were doing what they call cold mitten friction on the chest. And what was that doing? That was irritating the peripheral vasculature of the skin. It was causing vasoconstriction, and it was causing demargination of white blood cells all over the body so that these cells could circulate and get around. And you see this there in North America. You see it in Northern Europe, the same sorts of practices that have been done for hundreds of years. And now we start to understand the physiology behind it. It's increasing core body temperature. It's increasing the immune system. It's causing peripheral constriction with the cold, and it's causing white blood cells to demarginate. White blood cells stick to the outside of the red bloods of the blood vessels, and when you cause vasoconstriction, they get knocked off and they circulate and they do what they're supposed to do in the human body. So that's how I see cold being used. And I recently went to Australia and I talked to a physiotherapist by the name of Bruce Thompson, and he's quite phenomenal because what he did is he went through all of the protocols of John Harvey Kellogg, who was a real researcher. He actually wrote John Harvey Kellogg wrote a 1,000-page book on exactly what we're just talking about right now, of hydrotherapy, of hot, of cold, of different techniques and how to use it and how hot the temperature should be. And what Bruce has done throughout his whole life, this has been his sort of hobby. He's a physiotherapist or a physical therapist. Is he's taken those protocols and he's basically summarized them and he's made them available on the internet for anybody anybody who's interested in them, based on the diagnosis that we're talking about. And he's made it available at traditional.com, I believe is the website. It may be .com or .org. I'll have to look it up. We could put a link on the description for anybody who's interested. All one word, traditionalhydrotherapy.com or .org. And it's all there. All of those things are there for you to see. I mean, and this is what was used. So what's the efficacy of this? It's incredible. There is data. There are studies that show that interferon levels in someone's body when they come down with COVID is predictive of how well they'll do. High interferon levels predict a better outcome than low interferon levels. In fact, there's a gene on the SARS-CoV-2 virus that specifically inhibits the production, the ability of your body to make interferon. So we know that interferon is sort of the central core issue with regards to the issue with fighting SARS-CoV-2, interferon, influenza, all of these types of viruses. So there was a group of sanitariums in the Northeast back in the Spanish flu pandemic. The guy who actually wrote this article, it was in 1919. It was a guy by the name of Wells Rubel. He compared what was going on there with what they did with hydrotherapy and not using aspirin compared to the army hospitals at the time, who were using a lot of aspirin and not doing this, keeping people inside. And the mortality rates between these two populations was like incredible. It was 1/6 in the sanitariums. And so he wrote this up. He published it in Life and Health, May 1st, 1919. The whole thing is there about what they were doing. And so when I saw that, and then I started to look at the literature about what does body temperature do, And what we're talking about here right now, it became clear to me that as you start to come down with a virus, no matter what it is, that you ought to be getting out and increasing your body temperature in a safe way. So that, I mean, because increasing body temperature can have side effects, but doing it in a safe way. And this is what I do myself. If I'm coming down with something, I'm in the sauna, I'm in the hot tub, trying to increase my body temperature. It can actually increase interferon secretion by tenfold, according to some studies. And interferon is the death of any kind of viral infection that comes through into the human body. So anyway, that also changed my viewpoints about how we should be doing early treatment. So again, I'm looking for things that are complementary with technology. I'm looking for things that people can do at home. I'm looking for things that people can do without having to have a blood test or anything like that. And they can do it with very simple things that don't require a supply chain. This is why people might ask, why are you so interested in these sort of things? This is exactly the type of things that we would need to have if we had another pandemic, God forbid, and we had a supply chain disruption. Like, what can people do in their own homes without having to go to stores, pharmacies, physicians, and things of that nature? And this is something that everybody should have access to: hot water, towels, temperature, things of that nature. You don't need a hot tub or a sauna to do this. You can do this literally. This is how they did it 100 years ago, with towels, with microwave oven, electricity. If you don't have that, you could even make, on a stove, if you've got natural gas or propane, things that are very easy to do that can actually have an impact on someone's outcome in an influenza pandemic.
But it's even to me, it's so much more than that, right? Like, think of the disaster of chronic disease we all face. Every one of these things has an impact within, you name it, a disease, chronic disease. So, like, just the getting in the sun, and all spectrums is massive for everything from, uh, diabetes to heart disease. You've mentioned Weller many times. Like, this is not just for if you're sick, right?
No,
Like with
no.
a
Yeah.
cold or flu, right? Like, this is life changing. You mentioned the longevity, right? Even the Swedish study lays out longevity beautifully. But what what you hit on the finish too. Like, they're outside, right? They're doing the saunas, then they're going jumping in a lake. Like, it's not in a gym where they're doing under the blue lights doing hot and cold therapy, right? That's not what's going on either, right? So I think that's a whole nother caveat we need to do. So, uh, can you can you go into a little bit of that? Maybe the environment as much as to me, I think the solutions are pretty easy. Everybody's different. But before we go into that, for diet, this is I want your take on this. I own a farmer's market. This is what I do. I build out local food systems and strengthen Arkansas. That is, and then I try to cure cancer, right? It's just the 2 things there. The diet is local, seasonal, and natural that I advocate for, which is different for you in Southern California than me in Arkansas, than someone in Ecuador or Anchorage, right? Like, those are different. That is not a paleo, a keto, a carnivore, a vegan, a whatever diet. It is different depending on if it's whatever season that you have and whatever local to you. So, with that being said, that is one of the most beautiful ways of looking at how artificial our lives. We can't even grow plants without doing something crazy, right? Like hoop houses, artificial lighting, heat, but whatever you have to do. But somehow we think that we can live different than that. It's just mind blowing to me. So, what are your thoughts about just breaking the natural laws have consequences, and then we can go, whatever direction you want to with that. But if it is a natural way of doing something, when you break it one way or another, it we have a consequence that we get to deal with.
Yeah, I mean, I don't. I mean, there are laws, and then there are laws, right? So the laws that I would say of health would be, as we talked about with New Start, um, but I don't have a problem with shipping fruit and shipping goods and products. before the trains in the United States, the only way that you could have reliable food in the Northeast of the United States was salted meats, and this was something that was used quite a bit. And it was only until the 1850s, 1860s, 1870s that you started having the railway put down trains, and then you were able to get the oranges in California to the East Coast, and now you start to get a much wider variety of fruits and vegetables that could be produced all year round in the South that the North didn't have access to because they didn't have transportation. There was no refrigerators at that time. And so I actually think that was a good thing. I don't think that that was necessarily bad. Eating fruit out of season, eating these things, I think is better than the alternative of having no fruit, no vegetables. Look, I make no qualms about it. I think that a plant-based whole grain diet is actually very good. There's very good data on that, and that's where I come from on that. Maybe it's because of my upbringing, but I think the data is there.
The the thing about it that with is it's just not feasible to address a chronic disease epidemic that we're in with the way been going about it. Like, it didn't happen overnight. It's gotten progressively worse. So, what are the biggest factors that change? Our food system has changed. The way we live has changed. The fact that we as a dissipative structure have broken all the physical laws within a context, right? I think this is part of why we can go into that with the hot and cold therapy, or even the mitochondria, but we don't experience natural at all, right? I go back to what you said with you pull into a parking garage, you miss the entire day, and then you go home, right? So the impact of infrared or ultraviolet versus having an LED or fluorescent and that whole light spectrum, right? We've all seen the different graphs that show where you're peaking out, what you're missing. That is massive, right? And the diet piece to me, like, I mean, I think we have data points from all over, right? Like, we have Mongolians, right, that were carnivores. Well, we have more plant-based in equatorial, right? Like, we have all the different things that we can do, but what they had in common, right? If you just look at Weston Price's work, it was local, seasonal, natural to where they were, and they were always out in the sun, right? They were experiencing the temperature shifts.
I'll put it this way. If you've got a car, you've got to be able to make sure that you maintain that car. And maintaining that car is more than just putting the right fuel in there. It's also changing the oil filter, changing the air filter, rotating the tires, doing all the things that you know that you need to do because there's a lot of involved in a car. Well, the human body is far more complicated than a car. And so you've got to make sure that you're getting the right type of nutrition. That's like the fuel. You need to make sure that you're getting a moderate amount of exercise. That's like, taking the car out and driving it every once in a while, charging the battery. You've got to make sure that you're washing the car, you're cleaning the car. That's like water, right? Sunlight, temperance, air, rest, trust, all of these things. These are the major the major health laws of a human being. Let's go through now and talk about what you just brought up, which is how we're violating those things. So nutrition. Let's all agree to this, that processed foods are not good. So eliminating anything that goes into your mouth should look like what it does normally in the natural world. We can agree on that.
100%.
Yeah. Exercise. What are we doing that's bizarre with exercise? The media seems to show us that if we want to engage with exercise, it's got to be in a gym. It's got to be under fluorescent lights. It's got to be extreme. We've got to look like we're ripped or that we're the next model. This is a distortion of the type of exercise that actually science has shown is actually the best for us. I don't want to get into this too much, but they've done number of studies where they looked at moderate versus extraneous exercise. Strenuous exercise increases cytokines, it increases stress. It's not as good at reducing depression and anxiety than moderate exercise. So, the type of exercise that I would want patients to engage with if they want to have the best outcomes in terms of their health is not the type of exercise that we see advertised on television. It's not running marathons. It's not lifting and bench pressing huge amounts of weight. That actually makes your body weaker. In fact, so much so that there's studies that Olympic athletes, which obviously have to be at a high level, are actually at increased risk for having illnesses and things of that nature. There was a study out of the Fit Lab in at McGill University in Canada. I think it was Jennifer Heiss who did that. She's the director of the Fit Lab. They took regular, everyday 20-year-old students at the college, at the university, and they randomized them to moderate versus extreme exercise for the last 6 weeks of their term when they have all these exams. And they showed that versus control, the control group had a certain amount of depression, a certain amount of anxiety, a certain amount of cytokines, and that moderate exercise actually dropped that significantly. Whereas strenuous exercise not only did not negate it, it actually made it worse. So this idea of this J curve is really important when it comes to exercise. Okay, that's exercise. What about water hydrotherapy? We just talked about that. Even on a daily basis, when they do the studies, there's a dose response curve, and people in Finland who sauna, 4 or 5 times per week are better off than those that just do it once per week. And so, you're not really, Finland is a very homogenous population. You're not going to get this healthy user effect. Everybody saunas in Finland. In fact, the control group in Finland is those that do it once a day. That's the control group. They have more saunas than they do cars in Finland. So everybody's got a sauna, and those that do it more often have lower rates of death. I mean, that's pretty impressive. Sunlight, we just talked about, right? We could go through that data, but it's there. Temperance. Don't put chemicals into your body. Don't put harmful chemicals like toxins. That's just smoking, alcohol. These things are known toxins, and they can damage your liver and all sorts of things. So that's temperance. Air, getting outside not only has the benefit of getting you more sunlight, making you exercise more, but there's also phytoncides which come off of the trees and can improve your immune system tremendously. And then rest. So sleep. Where are we not sleeping? We're not sleeping because we come home, we work late, we have screens in front of our faces, we have to get up at the same time every morning, and we're not getting the benefits of that sleep. We're not getting the benefits of rest and rejuvenation, of all of those fasting related genes that come on when you're not eating, time restricted eating. All of those things are under rest. Then there's a weekly rest. Let's face it, those people that take time off every week and focus on what's important, turn off their email, turn off their texting, detach from technology, reunite with their family, what's important in their life. It gives them perspective in life and allows them to sort of adjust and see where they are. And then finally, that last, trust in God. People get a little bit skirmish when I talk about faith and God. It's kind of squishy. It's not something that's hard. Actually, you can do very good hard science on faith, believe it or not. You can take people who have faith, who believe in a higher power, and you can follow them and compare it to people who don't. And the results of those studies, time and time again, very consistently across the board, is that people that have faith in a higher power have less anxiety, have less depression. They do much better at the end of life. They're not afraid of dying, and they have a higher quality of life. I mean, this is the science, and you can either ignore it or you can chalk it up to something else. But the facts are that that's exactly what we see. And people who have that support obviously are going to do better because they feel like they're not going through life alone. Part of that is also community. People who have a community, who are there with someone. We know that people that live in a family, live with a family, have better support. We know this. This is no brainer. When we have patients at the hospital and we discharge them, hey, do you have someone in the local area that can take care of you? Well, an extended church family or community is just like that. If you're not, some people aren't blessed with children. Some people don't have a spouse. But if you're part of a community that can take care of you and will take care of you, that's obviously a plus. So again, these are the 8 laws of health. These are the practical areas where we are falling short, and the prescription is pretty obvious.
I love it. I love it. Now, definitely not gonna be squeamish on the whole faith thing, at least on this, this podcast. I think that's, paramount. I think back to that. I mean, that's the whole reason that sowing prosperity is Galatians 6:7. Do not be deceived. God's not mocked. Whatever man sows, this he shall also reap. And so, like, there's that. And then, when Lander was diagnosed, I said, the doctors are going to do their part, God's going to do his part, and Daddy's going to do his. And I've taken that to heart to try to understand cancer and bring it together. I appreciate you talking about it. I appreciate you being who you are. And as I understand more, there are two things are, right there in your face is we don't know anything at all. And I have a stronger faith at the design is just beyond incredible, right? And so just I have more faith. And thank you so much for taking the time doing what you're doing. In a lot of ways, you are uh, going against the grain, but you're also trying to do it in the way that it's true to you. So just thank you for what you do. I thoroughly enjoyed following along, and will continue to do so.
Well, thank you so much, Logan.